Hi everyone, Sarah Wofford here. Some of you have asked questions about setting up free body diagrams and using those to set up the equations of motion. So I thought I would give a little demonstration. This is right at the heart of physics really, because you're using physical reasoning along with the laws of physics to determine what the equations should be, and then set those up and use your mathematical skills to solve them, and then use physical reasoning again at the end to evaluate the answer that you get. We're just going to do the setup here. So I start with a sketch, and in this case I'm going to use the example of a block sliding down an incline. So if I use like where it's the ground, it's the incline, and we have a block here, then this is our physical situation. We have some angle here, and we have motion sliding down. So we have some velocity downward. You want to pay attention to what objects you have in your situation, and for a free body diagram, you isolate one object. In this case, it's pretty easy because I'm probably not so interested in the forces on the incline, although there are situations where if you're an engineer, you might be. In this case, we're looking at the motion of the block. So we're going to look at just the forces that are acting on the block. And I'll go ahead and draw my vectors right on here, but you could also draw them separately. For example, you could just say, all right, the center of mass of my block is like this, and I'll draw all my forces there. Just for the sake of having room, I'm going to draw them up here. So we have, you know that gravity is pulling downward, so I like to draw my forces all acting on the center of mass of the object. I think for me it makes it clearer. So gravity acting downwards, label all your forces so that you know what they mean. Force of gravity acting downwards. Then you have a force of support from the surface that points perpendicular or normal to the surface, right? So that's your normal force pointing perpendicular to the incline. So that's going to be this way. So a force that is normal to the surface. So there's my F sub n, my F sub g. And then you know that, well, gravity is pulling downward, but that's this force. What else is there? There's the force of friction between the block and the incline. And if the block is sliding down, friction is pointing in the opposite direction along the incline. So that's going to be this way. Force of, I'm going to call this Kf for kinetic friction. That looks probably too small to read. Let me make it bigger and darker. Force of kinetic friction. Is that better? I hope so. Let me do that with these two. Normal force and force of gravity. Okay. All right, so then you need a coordinate system because we have 2 dimensions of motion here, and sometimes you might have 3. And you choose your coordinate system so that it's convenient for you to work with. You might choose a coordinate system that allows you to take the fewest components of vectors, or you might choose a coordinate system in which one axis lines up with a direction of motion. In this case, those would be the same thing because we know that there's motion down the incline. So if we were to orient our axis so that our coordinate system so that one axis goes along the incline, then I don't need to take components of that force or that one because those are parallel and perpendicular to the incline. So only one vector would I need to take components of. If I made my axes parallel to the ground and perpendicular, then I would need to take components of both of these forces. And my motion is also not in line one of the axes. So we're free to orient the coordinate system in any way that is useful to us. So let me try red and see if this will work here. So I make my y-axis like this, and my x-axis like this, that is not very visible, is it? Let's try this one. X, Y, my markers are getting low. All right, so y-axis up that way, x-axis down this way, so then we're sliding in the positive x direction. Okay. Then we need to write Newton's second law, F equals ma, net force equals mass times acceleration in each of the two directions. So x direction, I have net force in the x direction is equal to the mass of the block, so my mass of the block, times the acceleration of the block in the x direction. So on the right side are all of the forces that act on the block in the x direction. That's the left side, sorry. And on the right side are the mass of the object you're analyzing and the acceleration of the object you're analyzing in that direction. So we also need a y direction. Net force in the y direction equals ma sub y. This is where I always start. So then, what are all the forces in the x direction? Well, positive direction, x direction, I need to take components of my force here that is not in line with my axes. I should do that. So I have a component that is parallel to the y-axis and one that is parallel to the x-axis. So those have to be perpendicular to each other. So I draw the arrows so that one component is parallel to y, one is parallel to x. They're perpendicular to each other. So my actual gravitational force vector, the weight of the object is straight down, but then I have a component here, and this triangle is similar to this triangle. So small angle here is equal to the small angle here. And therefore, the opposite sign, that's the sine. The adjacent side is the cosine. So this side is FG sine theta, this side is FG cosine theta. So along the x direction, I have this component, which is FG sine, opposite side, sine of the angle, opposite side, sine. Then in the opposite direction, I have the force of kinetic friction, and that equals whatever my mass and acceleration are down this way. So if your problem tells you that it's constant velocity, then this would be 0. Right? But if it's not specified, then this might be an unknown. This might be what you're looking for. Whereas if you're given a constant velocity, you might be looking for the force of friction, for example. All right, so then in the y direction, I have the positive y, I have this normal force. In the opposite direction, I have this component of the gravitational force, so that's the adjacent side, cosine, force, gravity times the cosine of the angle. And now here, I know from the situation that that acceleration is 0, because this block is not leaving the plane. So this is another bit of physical reasoning. If we know that the block is sliding down the plane, that was part of the initial conditions, it's not jumping off or sinking in, then we know that the acceleration perpendicular to the plane is 0. So that's the setup of those equations. Then we also need any other relationships that we might know between these forces, or between geometrical quantities, or whatever there might be in the problem. So for example, we also know that this normal force, this frictional force is related to the normal force, right? So if it's kinetic friction, then we have force of kinetic friction is equal to the coefficient of kinetic friction times the normal force, right? You also know that the force of gravity on the object is equal to mg. It's weight times the gravitational acceleration. So you have these relationships between forces and other physical quantities. And then these are Newton's second law in the x and y direction. So then you can substitute these into here wherever you need them. You can solve this and substitute into here if you need to. Make whatever substitutions you need to solve your problem mathematically. The physics is done. We've set it up with physical reasoning. We made our diagram, and then we used what we knew from this situation with the coordinate system to write down Newton's second law in each direction. We just added up what are all the forces in the plus x and minus x directions, all the forces in the plus y and minus y directions, and whatever we know about the accelerations. And there it is. Then the rest is math. Once you get to the end, you want to use physical reasoning again on the answer to make sure that it makes sense. Do the magnitude and direction, sign, the units, do they all make sense based on what you were looking for?